Hello everybody, welcome again to my channel. Today we'll be discussing about special operational procedures and hazards. Also, you can check out other videos on air regulations right here in my channel. So let's get started. Okay, so let's begin with the minimum list equipment. So this is a list which contains all the equipments with the help of which the flight can be continued in case any system or any instrument in the flight becomes inoperable. So with reference to this list, the pilot can make a decision as in if he wants to continue the flight or not. So this list is available in the operations manual, so he can refer to the operation manual and make a decision. And also there's something known as the master minimum equipment list, MMEL. So this is drawn by the manufacturer and is approved by Dgca. So this is the equipments on which certain in-flight failures can be allowed and the conditions under which this allowance can be accepted. Okay, fine. Moving on to the aeroplane flight manual, AFM. This is approved by the state of design. So any aircraft is allowed to fly only if it is having a certificate of airworthiness, as well as he is flying within the operating limitations of a flight manual. So it contains all the factors, it accounts for all the factors which affects the performance of the aeroplane, and it includes everything as in the temperature, wind, runway slope, surface conditions, right? In fact, including the water and ice, etc. So all those things which affect the flying of the aircraft, it includes it. That is the airplane flight manual. Let's come to ground de-icing. So before starting, you might know that even the thinnest layer of the ice is very much hazardous for the flight, and that is why that ice layer has to be removed, and it is not allowed to fly in such condition if the aircraft is not equipped or if it is not certified to fly in the icing condition. And also for the night flying, it should be equipped with the system which eliminates or detects the formation of the ice. So many de-icing and anti-icing techniques are followed in order to keep the aircraft in the airworthy condition to fly. So these can be fluids or any other systems. So some de-icing fluids are used on ground, but they can only be useful when the aircraft is on ground. Once it becomes airborne, in that case the onboard system will take over, right? As I told you that very little amount of ice also becomes hazardous. So if you say that the thickness of the ice is 0.4 millimeter, that is also very much hazardous, and it makes the surface rough. Even the snow, ice or frost, they affect the proper operation of the aircraft. What happens, it makes the surface rough, and so it affects severely the lift and increases the drag, impairs the maneuverability during takeoff or initial climb phases. So that is why it is important to take certain measures which removes the ice from the surface of the aircraft. So ice can be formed or it can be accumulated on the aircraft in many ways. Let's look into that. The first one is fuel which is there in the wings. Okay, it is of very low temperature. So since it is of very low temperature, it makes the temperature of the metal with which it is in contact with very much cold. So the surface of the wings becomes too cold, and so it goes beyond below the 0 degree Celsius, and hence the ice formation occurs. This is also known as cold soaking. So if they ask you in the question what is cold soaking, so this is what it is. And also it can form if the aircraft is flying in a very high altitude where it is very cold, and eventually they do a quick descent and come to a humid, comparatively humid environment, then also ice formation can take place. And how are these ice removed? Well, one is like heated aircraft de-icing fluid, ADF it is called. So with the application of this fluid, the ice can be removed. So one major difference between de-icing and anti-icing is that de-icing means that the ice is already accumulated on the aircraft and you want to remove that ice. And anti-icing means there is some anti-icing fluid also. So if you apply anti-icing fluid on the aircraft, it will not allow the ice to form in the aircraft surface. So that is the difference between anti-icing and the de-icing. Okay. So GIDS is the ground ice detection system. So the ice can be detected on the ground by some special tactile inspections, and that is known as that is done with the help of this system. And that is all about the icing. Moving on to the next topic. Bird strike. So the birds can come from anywhere at any time and they don't even give the warnings, obviously. So for that what you can do is this, that you can wait or abandon your departure if you see a flock of birds going around from that area, and inform the ATC ASAP that there's a flock of bird. And this bird strike majorly occurs, 90% of the bird strike, it occurs under 500 meter. And also they say that shell crackers, they can scare off the birds. So these things are undertaken, and so the bird strike can be avoided to a great extent. Moving on to departure climb. So any aeroplane operating procedures for departure climb will ensure that the safety of the flight operations and minimize the noise which comes out and affects the people around that area. So there are various noise abatement procedures undertaken. So noise abatement procedures to be executed below 240 meters above the aerodrome elevation. The noise abatement procedures should not be used where the wind shear warning exists and downburst is suspected, and also don't exceed the maximum acceptable body angle. These are some of the things taken into account while you are departing, and the aerodrome has to take care that the noise does not go beyond certain limits, so that there is a proper systematic flow of the air traffic without disturbing the surrounding environment. Fine. Similarly, for approach also, various noise abatement procedures are taken into consideration, but one thing that reverse thrust does not help in this, so you can leave that. And also for noise abatement, aircraft should be in final landing configuration. So either you can say that they will be in the outer marker of the ILS if they are following the ILS approach, or at a point 5 nautical miles from the threshold of the landing runway, right? So then only the noise abatement procedures can be carried out. And then noise preferential routes are followed. So the ATS routes are formed in such a manner that they do not disturb the surrounding area. So to avoid the noise sensitive areas, the ATS routes are formed, keeping that into mind. And then the noise abatement, not a determining factor in runway designation. So if the crosswind exceeds 15 knots, tailwind exceeds 5 knots, and the runway is not clear or dry, in that case noise abatement will not be the one which will be affecting the runway designator. So these are some more important stuff that has to be given the priority, right? And noise is the secondary thing. Fine. Let's move on to the fire and smoke. So the combustion occurs due to 3 elements. oxygen, heat and fuel. With any one of them not available, the fire won't be there, combustion won't happen. So all these three elements are required for combustion. And also it is important to learn about fire because in most of the cases damage as well as loss of life, injuries or death, all these things are due to the burn and fire. So that is why it is important to learn about it. So the fire is categorized into 4 classes: A, B, C and D. So class A is when wood and paper, cloth and plastic, these things are involved. So they can be extinguished by water and glycol extinguishers. So any liquid which has a lot of water, large percentage of water, even the coffee, tea, juice, they can be helpful for extinguishing class A fire. But don't use the liquids which are containing alcohol. Okay. The smoke comes out to be gray and brown in color. Okay, they can be quite thick depending upon the quantity of fuel there. Okay, then class B is due to the flammable liquids, hydraulic fluid, oil, tar or aircraft fuel. So how can you extinguish this? By foam or halon. This is the major thing which is helpful in extinguishing the fire. It is black, its smoke is black in color and very much thick. Electrical equipment fire is the class C category. Non-conducting mixture or halon is helpful for extinguishing this fire, and it is gray and white in color, the smoke, and it is also very fine and disperses rapidly. Class D is a flammable metal fire. So special powder extinguishes it. Okay, and because of the possible chemical reaction between the burning and the extinguishing agents, so we never use halon fire extinguisher in class D, never ever. So class A and C are the most common fires that happens, and hand fire extinguisher lasts for about 8 to 25 seconds depending on the size of the extinguisher and the type of fire extinguishers. Okay, so there are various types. First is the halon or the BCF, which is green in color. The cylinder which is there, no extinguisher, it is green colored, and it is useful for A, B, C type of fire. And the carbon dioxide is black color extinguisher, which is helpful for extinguishing class B and C type of fire. Dry powder, blue color, for class D fire, and dry chemicals is for A, B, C, blue color, and H2O is red color cylinder for class A fires. Halon is 3 times as effective as carbon dioxide. In class A fire, using halon, surrounding area must be cooled down by a non-alcoholic liquid. Okay, and portable breathing equipments, PBE we call it, that is to be used for if you are using halon, because it is hazardous to health, and even it is not suggested to use halon at many times. So they are finding an alternative for it because it depletes the ozone layer. So till 2024 28th November they have permitted the use of halon only in the cargo compartments. In other areas any other alternative is used. Okay. The location where halon is kept, at least one halon 1211 type. It is in the flight deck, galleys, personal or cargo compartments. So actions in case of overheated brakes after aborted takeoff and landing. So in these cases, it is obvious that the speed of the wheels is very high, and if all of a sudden the brakes are applied, the kinetic energy is converted into the heat energy. So that heat may cause the overheating of the brakes, and in certain cases the brakes performance may get lost, and even the tires may burst, or fire can also occur, and it may also even affect the movement of the aircraft. They may even collide or deflect. They may get deflected from their path. So in that cases, certain actions have to be taken, to avoid the overheating of the brake. In case this happens, the first and foremost thing that needs to be done is ask for the fire and rescue services, and also if required, then emergency evacuation should be done as soon as possible. Okay. Let's move on to a very important topic, decompression of pressurized cabin. So, as you might know that while we fly upwards, as we go higher and higher, the atmospheric pressure becomes very low, which is not a suitable condition for normal living. And that can cause a lot of health problems, and people cannot survive in such conditions. So that is why at high altitude the inside pressure of the aircraft should be maintained in the normal one, so that the people as well as the cabin crew and the flight crew, they find it comfortable to operate and stay in that environment. That is why the compressed air is pumped into the aircraft. So the cause of failure of such pressurization can be due to structural failure, the failure of a window, door, or any pressure bulkhead, for example, or in flight explosion. So these can be the causes for structural failure, due to which the pressure inside the aircraft that is affected, and also pressurization system failure. So there is a pressurization system inside the aircraft which maintains the proper pressure inside, and there are a lot of valves inside which helps maintain the pressure. So that can also fail, in which the pressurization may be affected inside. Also some deliberate actions, such as if there is a smoke in the cabin and the captain, if they try to take some measures, some drastic measures, that can also affect the pressurization of the aircraft. Rapid or explosive decompression. So this is the decompression which occurs very rapidly and it is unexpected. The rate at which this decompression occurs is very much greater than the decompression rate of our lungs. So that is why the lungs can even get damaged. Right. Sometimes it takes even less than 0.5 seconds. So that is considered as explosive. Right. So the cabin air may even fill with dust, debris, fog, and cause associated to drop in temperature and change in relative humidity. So the crew may be momentarily dazed and shocked, especially if the event has occurred unexpectedly, and they may even therefore be slow to fit the oxygen mask. Slow decompression is also similar to rapid decompression, just that it takes a little longer, and so the time is that we get for reaction is a little more. So it can be, the severity can be reduced up to some extent, but decompression is decompression. It is very much hazardous, right? So crew and passenger incapacitation. So due to decompression, hypoxia occurs. Hypoxia is a lack of oxygen in the body. So the amount of oxygen that is needed for normal functioning of the body, that we are not getting. So it is not sufficient. So supplementary oxygen is required in that cases, right? So that is an hypoxia. Depressurization warning is required when the cabin altitude exceeds 10,000 feet. So up to 10,000 feet the body manages, with the amount of oxygen which is there. But but if we go above 10,000 feet, then supplementary oxygen is required, and the altitude between 13,200 feet to 14,000 feet, the oxygen mask will drop down automatically, but not higher than 15,000 feet. Okay. In case decompression occurs, then there are only two things that you can do in the flight. First thing is that take oxygen mask and you take oxygen as much as you can. So it is due to so hypoxia occurs because there is insufficient oxygen. So you might want to have more oxygen in your body. And also the first and the foremost thing that the pilot needs to do if it's a decompression situation in the flight, that is he needs to do the emergency descent. So if he descends below 10,000 feet conventionally, then supplementary oxygen won't be required, and that atmosphere be a little bit suitable for people to survive. That is the two things that you need to take care. Fine, moving on. Wind shear. Wind shear can be vertical or horizontal wind components that may be produced due to any reason, maybe thunderstorms, cyclones, etc., etc., and they can affect the movement of the aircraft. So hazards are that the wind shear vector exceeding 25 knots within 500 feet above ground level, then it can be hazardous. If you are above 1000 feet, then 40 knots is the speed of the wind, then it is hazardous. 15,000 feet, 50 knots, and loss or gain of IAS, indicated airspeed 20 knots or more within 1500 feet AGL, then that is hazardous. Okay. Also, the aircraft capable of reporting the wind and altitude both above and below the shear layer from the flight management system are to do so. Right. So the pilots without this equipment should report wind shear by stating the loss or gain of airspeed and the altitude at which they have encountered it. Right. Moving to microburst. Microburst is another dangerous phenomena. In this, you can expect headwind, tailwind, depending upon where your flight is and at which position that microburst is occurring. So mostly its size is approximately 1 nautical mile in diameter at 2000 feet above ground level, and with a horizontal extent at the surface approximately 2 to 1/2 nautical miles. Intensity. So vertical winds is as high as 6000 feet per minute and horizontal wind is 45 knots. Type. Okay, so heavy rain occurs in areas where the air is very humid, and however in drier areas falling raindrops may even they evaporate before reaching the ground, so it is known as virga. And then we come to duration. It may last to about 15 minutes or so, but the maximum intensity which we will see is only for 2 to 4 minutes. So I'll show you a picture. So this is a picture of a microburst, and this is a runway. So if you see, this is a headwind from this direction, and if you are going here, you'll encounter tailwind. So on takeoff, the aircraft may encounter headwind first, which will be enhancing the performance. And when you reach here, then downburst occurs. So you can even go on this path, and even you can crash at this path. If you are successfully able to keep your flight in the air and not crash its path, then you will be encountering tailwind in this direction. That will again decrease the performance. So the most important thing that you need to keep in mind while you encounter a microburst is that avoid it. Okay, you are advised or suggested that don't go around microburst because you may have a chance to crash. If in case you encounter a microburst all of a sudden in your path, then what you will be doing is that you need full power and pitch attitude consistent with the maximum angle of attack of your aircraft. This thing has to be done, then you can be good enough to cross that microburst area. Fine. Let's move on to the next topic. Wake turbulence. So the airfoils produce wake turbulence when they are producing lift. So as you can see, this is a very stupid diagram actually of an aircraft, but as long as you understand it, these are the wings. So above the wing, as you know, it is low pressure area here and here, and below it, it is a high pressure area. And always the winds tend to move from high pressure area to the low pressure area. So in this wing, the air will be going like this, curling up in the clockwise direction and going up to the low pressure area. And in case of the right wing, it will be going in the anti-clockwise direction. So as the aircraft progresses forwards, it forms a small helix sort of a way, path, and this thing is known as wake turbulence, or even vortices you call it. So in this, you will be finding that it is clockwise in direction, and this side will be anti-clockwise direction, and they may extend up to 5 nautical miles backside. And vertically, if you see, from 500 to 900 feet they can extend. The strongest wake turbulence is seen in big aircrafts having huge weights, as well as if they're flying in less speed, smaller speed, then you can see this wake turbulence to be much stronger as compared to a lighter aircraft flying in the greater speed. Okay, we'll be talking about the categories of wake turbulence now. There are 4 categories: super heavy, which is denoted by S, heavy denoted by H, medium by M, and light by L. So in the super heavy category, the separate designation that currently only refers to the Airbus A380 to 800 maximum certified takeoff weight should be 5,60,000 kg. Then in that case, the aircraft will be said to be in a super heavy category, and the wake turbulence is very strong in this case. And in a heavy category, the weight of the aircraft is 1,36,000 kg or more. In medium, it is 7,000 to 1,36,000 kg, and in light aircraft, it is less than 7,000 kg weight of the aircraft. Then it is called a light wake turbulence. Fine. So if you want to know the examples of this, then in the light category, the training aircrafts, the Cessna, Islander, Piper, all these things are included. In the medium, the Boeing 727, 737, and also Airbus A320, 321, these are also under the medium category. But when you come to the heavy category, it will be Boeing 777, Boeing 767, 747, Airbus 300, 310, 330, 340, 350, right? All these things are coming under this category, and I already told you about the super heavy category. Next comes the wake turbulence, longitudinal separation minima, arriving aircraft, departing aircraft. We'll see it all in the table. So let's go. So you can look at this table. The leading aircraft is Airbus A380 to 800, and the following aircraft is medium. In that case, the separation maintained should be 3 minutes. And if the following aircraft is light, then 4 minute separation. Heavy is the leading aircraft, and medium is the following, then 2 minute separation. Heavy, medium, leading, and light, then 3 minute separation. For the departing aircraft, this is the table that you need to follow. You can see it. So this is when the departing aircraft are following the same track, or if their track are separated but parallel, they are separated by 2,500 feet, or they are having crossing tracks, and the altitude which they cross each other is same or less than 1,000 feet. So that is the when you have to follow this. Or in case the intermediate part of the same runway, if you're following, and this intermediate part of the parallel runway separated by less than this, then you have to follow this table. the displaced landing threshold. So a separation minimum as specified in this table will be applied. Okay, fine. So actually the distance based wake turbulence separation minima in this table shall be applied to aircraft being provided at the ATS surveillance service in the approach and the departed phases of the flight is there. Okay. So an aircraft is operating directly behind another aircraft at the same altitude or less than 1000 feet, and if their track is again separated by 760 meter or 2500 feet from each other and they are parallel, so in that case this table has to be followed. So the leading aircraft is super heavy and following aircraft is light medium, then 3 minutes separation for departure as well as for arrival. And in case of heavy arrival and medium arrival also, if the following aircraft is light, and in this case light and medium, 2 minutes separation, and in heavy departure and medium departure 2 minutes separation for this following aircrafts. That was the time based separation. This is the distance based separation. So as you can see that in case super heavy and super heavy aircraft are there, and sometimes in heavy also, then distance as such the distance based separation is not required. But in case they are different, right? So if it is super heavy here and medium light heavy in this, then 6 nautical miles, 7 nautical miles. So it basically is from 5 nautical miles to 8 nautical miles. You just have to take care that if the preceding aircraft is very much heavy, super heavy, and the following aircraft is a light one, then the separation needs to be a little bit more. Right, that thing has to be kept in mind and you will be able to remember it. Last part of wake turbulence, dealing with it. So how do you deal with it? You need to make sure that you are maintaining proper minima, and also you have to be either above the glide slope to avoid the wake encounters, or stay at where you are behind the larger aircraft if you're following, right? So this is the only 2 important things that you need to keep in mind. Otherwise, small points are lot of small points are there, but these are the 2 major things that you need to take care. Next, security. So reporting the acts of unlawful interference first thing. So if any case of hijacking or unlawful interference on board the aircraft happens, then the commander, or in the absence of the commander, the operator, they will have to submit, without delay the report of such an act to the local authority as well as to the authority of the state of operator. Okay. Next thing is emergency and precautionary landing operations in various terrain. So in case of terrain, we'll be talking about forced landing and precautionary landing. So forced landing is defined as the immediate landing on or off at the airport, which is due to inability to continue the flight further. So this may be due to engine failure. Okay, and precautionary landing does not mean that immediate landing is required, but that a premeditated landing is required on or off the airport. So when further flight is possible, but it is not advisable to continue. Right, so this might be due to fuel shortage, or if you are lost and any weather is there and it is deteriorating, then you have to make such precautionary landing. Finally, ditching. So ditching is defined as the forced or precautionary landing on water. That is ditching. Fuel jettisoning. This means dumping of the fuel in air in urgent situations. So only thing that you need to keep in mind is that you cannot dump the fuel in the areas where you are nearby the city, towns, etc. And this has to be done preferably over the water and away from the areas where thunderstorms etc. are occurring. Also, it should be above 6,000 feet, and duration of fuel dumping should also be taken care. Okay, so talking about separation now. So if you are flying and there is any aircraft which is dumping fuel, then it is advisable that you don't go very near to that aircraft. So at least 10 nautical mile horizontal distance should be there. Vertical separation if behind the aircraft dumping the fuel within 15 minutes flying time, or a distance of 50 nautical miles by at least 300 meter or 1000 feet above the aircraft dumping the fuel, or 3000 feet below the aircraft which is dumping the fuel. Right, this is what is written. Moving on to communication. So aircraft will maintain radio silence during fuel dumping. Okay, and then transport of dangerous goods. So more than half of the cargo carried by all modes of transport in the world is a dangerous cargo. This is for your information, and it can be explosives, corrosive, flammable, toxic, or even radioactive. So these dangerous goods are essential for worldwide variety of industrial purposes, commercial, medical, etc. So this is important. That is why it is allowed to carry the dangerous goods, but obviously permit needs to be there for carrying such thing. Permission has to be taken. Okay, and because the advantages of the air transport, a great deal of this dangerous cargo is carried by the aircraft. Okay, then the dangerous goods forbidden for the transport by the air unless exempted. The articles and substances that are identified in the technical instructions as being forbidden for the transport in normal conditions, and infected live animals. So these cannot be carried. Otherwise, all the things can be carried on board. Contaminated runway. What is contaminated runway? Braking action, brake coefficient. So runway surface friction is directly relevant to the braking action, which will be available to an aircraft decelerating after touchdown or after the decision to reject the takeoff, right? For most multi-crew aircraft, anti-skid braking system will be fitted that will avoid immediate stop, and they will let the wheels to rotate, and so the skidding will be avoided. Okay, so that is an anti-skidding thing. And then landing wet and contaminated runway. So an operator shall ensure that when the appropriate weather reports or forecast or the combination of these are given, then the runway estimated time of arrival has to be told, and they have to tell that the runway is either wet or dry, and the landing distance available, it should be at least 115% of the required landing distance. Right, fine. The last topic is dynamic hydroplaning. Dynamic hydroplaning is when you are landing on a surface with standing water deeper than the tread depth of the tire. So the brakes can lock up, and anti-skid system is used to minimize the hydroplaning effect. Thank you so much for watching. That was the end of the video. If you liked it, do give it a thumbs up and also subscribe to my channel. We'll see you in the next one. Bye bye.